Alright, so today we talked about in class how to use corresponding parts of congruent triangles to say two figures are congruent. So if you're on Google Classroom, if you missed class or you need to see this again, just go to Classroom where I've uploaded the 4-4 notes, and you can follow along with this video and complete those notes and get caught up. Now, recall what we mean by two figures being congruent. If I've got these two chairs from the same manufacturer, they're going to be congruent because they want to have them coming off the assembly line with the same parts and be able to quickly assemble them. So I've got these two figures. I know that the two chairs are congruent. So if I go and do something like measure the back side of the chair and find out, hey, this thing is 16 inches wide. Without even measuring this chair over here, we know that that one is also 16 inches wide. Likewise, if I look at the angle right here formed, where the chair meets the ground, and I find out that that angle is, say, 48 degrees, then I know the corresponding angle over here on the other chair must also be 48 degrees. So if two figures are congruent, then I know I can look at their corresponding parts and declare them congruent without actually having to go and measure it. And that's the whole concept in this section, except we're not talking about chairs, we're talking about triangles. So look at this set of triangles right here. This should be on your skeleton notes. And notice that this time they're asking us not to prove triangles congruent. They're asking us to prove KB, side KB, is congruent to AC. But in order to prove that KB is congruent to AC, I'm going to have to first show that triangle KBC is congruent to triangle ACB. Once I know that this triangle and this triangle are congruent, I can say, hey, their corresponding parts must be congruent. It's kind of like if this chair is congruent to this chair, the back of the chair is the same width as the back of the other chair. And that's the whole ideal behind it. So take a look at these two triangles, and I want you to ask yourself, why are these two triangles congruent? It's just like that worksheet we did a few days ago. Is it side, 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 angle, angle, side? Which postulate makes them congruent? So looking at this, we know that this angle is congruent to this one. This one's congruent to this one. And then this side is congruent to this side. So the side right here congruent is not sandwiched between the angles. So we've got angle, angle, side. That's the postulate I'm going to use to show the two triangles are congruent. So let's go ahead. I'll back this up. And we'll do that. So we're going to go through this just like we do any other proof. I'm going to say, or proof that two triangles are congruent. I'm going to put these two givens in here because they directly help me out in the beginning. So angle K is congruent to angle A, and angle KBC is congruent to angle ACB. Why? Because it's given to me. Now what does that do for me? That gives me already, I've got two angles in here that are congruent. I'm going to use angle, angle, side to show the triangles are congruent. There's my two angles already. And then I need to show that BC is going to be congruent to itself. So side BC is congruent to side BC, and the reason is the reflexive property. So that gives me a side. Now I can say that the two triangles are congruent. So triangle KBC is congruent to, remember the first one doesn't matter the order, so your K corresponds to A because they're both two arc marks. B corresponds to C because they're both one arc mark. And then, what's the other one? C right here corresponds to that B. And the reason is angle, angle, side. Now I'm not done with my proof because they didn't tell me to prove the two triangles are congruent. They wanted us to see that KB, or show that KB and AC are congruent. So remember a few days ago when we talked about these congruency statements. If we have a congruency statement like this, even if we didn't have all this mess that's on this screen right here, if I just wrote on the screen that triangle KBC is congruent to triangle ACB, you should be able to tell me 6 things. You should be able to tell me that K is congruent to angle A, angle B congruent to angle C congruent to angle B. Those are the three angles. And then you should be able to tell me about three sides. You should say side KB is congruent to side AC, side BC is congruent to CB, and then the first and last, side KC, is congruent to side AB. All six of those things. Now, we don't need to write all six down below, but that does, I did say this at some point in all that rambling, that KB is congruent to AC. And notice the first two listed here, KB and AC, are congruent. So that allows me to write it down below. KB is congruent to AC. And the reason is this: corresponding parts of congruent triangles are congruent. Now, it's important to know that, or note that this must be somewhere in your proof if you're going to use this statement right here. Because it makes no sense to say that two parts are congruent because the triangles are congruent if you have not shown in your proof that the triangles are indeed congruent. And in order to say the triangles are congruent, you've got to have all this mess up above it to prove that those two triangles are congruent. So it all should directly flow from that. Now, I know that this is a lot to write out. And being a math teacher, I don't care for writing too much. So I'm perfectly fine, instead of saying corresponding parts of congruent triangles are congruent, you can say kipetic. Okay? And what I mean by kipetic is this: C, P, C, T, C. Just like it sounds, is how it's spelled, kipetic. That means corresponding parts of congruent triangles are congruent. Okay? So instead of writing all this out, you can just put that in for your reason. Let's look at the next one. So you're given BA and DA are congruent. That's the 1 dash. CA and EA are congruent. That's 2 dashes. And we want to prove that angle C right here is congruent to angle E. Pause the video and try the proof out. And then come back and see what I got. Now, remember that before we actually do a proof, we want to come up with a plan. So we want to show C and E are congruent. I'm going to say, if I can show these two triangles, the one on the left and the one on the right congruent, then I can say that their corresponding parts, angle C and angle E, are congruent. So how do I show these two triangles are congruent? Well, I got one side congruent to a side, another side congruent to a side, and notice the vertical angles right here are congruent. So I'm going to have side, angle, side, congruent to side, angle, side right there. So I'm going to use SAS. So now I need to put that all in my proof, what I just said there. So I'll start with what's given to me. BA is congruent to DA, and CA is congruent to EA, and that's given. So that gives me a side and a side. And then I've got my vertical angles. Angle CAB, CAB, is congruent to angle EAD. And that's vertical angles are congruent. That gives me an angle. Now remember, we can't do the cuss word and the cuss word backwards. So you might think, hey, that's the cuss word backwards. But it's not the cuss word backwards because we don't pay attention to the order we put in our proof. None of these three lines here are dependent on one another. I could put them in any order I want. What matters is, on the diagram, it's SAS. And so that's why I'm going to say, hey, triangle CAB is congruent to triangle EAD, and the reason is SAS. Now that I've got the triangles congruent, look, and the corresponding parts should match up. So C and E should be matching up, and they are. Angle C is congruent to angle E here. It's also worth mentioning that up here, let me erase all this mess. How did I know to write up my congruency statement like this? It's not because of that angle up there. The reason why I know that C corresponds to E is because, look, they're both across from the 1 dash mark. C is across from the 1 dash, so is E. So C and E corresponds. If I write C first, E goes first. B is across from 2 dashes. Across from 2 dashes over here is D. So if I write B last, D goes last. And then in the middle, I've got A on the left triangle is across from no dashes, and A on the triangle on the right is across from no dashes there. So I write those in order, and now I can say that angle C is congruent to angle E down here. And the reason is Kipitic. Corresponding parts of congruent triangles are congruent. All right. For our last problem here, we're going to prove, we'll see how congruent triangles are useful for measurement. So we got Thales, a Greek philosopher, is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together. Standing on the top of the tower, he could hold one stick vertical. So if you imagine a compass, he's holding one stick vertical. And then the other, he's going to line it up with his sight to whatever object's out there. So in this case, he's holding it vertical right here, and he's lining it up with the line of sight to that tree. So, where are we in here? With his compass setting, he would then find the landmark on the shore, and with the tilt stick, how far from the ship is the base of the tower. No, I didn't really read that too well. Just pause the video, read it yourself if you want to. Basically, this is what he's doing. He has several landmarks over here. He might know that this one is 10 meters away, this one's 20 meters away, this one's 50 meters away from the base of the tower. So he can see a boat out here, and he locks this angle in. Then he flips around to known landmarks, and he finds out which one matches up best with the angle headed towards the boat. So if it lines up with the tree right here, and he knows the tree is 50 meters away, then the boat must also be 50 meters away without having to go out in a boat and measure it himself. He's got this set up convenient, and he can figure out how far away is a boat. Now, what it wants us to do is prove here, let me erase some of this. It wants us to prove that RS is congruent to RL, given that we know these angles right here are right angles and these angles right here are congruent angles. Prove that this distance, the distance he's estimating, is congruent to the distance he's measured over here. So I've moved this picture like this, and just go ahead and draw on the diagram what's given to you. We've got right angles congruent. We've got angles up at the top congruent. And now let's do this proof. So you got two triangles. If you can't see it, this is what your triangle looks like. One right there and then one right here. We want to show that this side is congruent to this one. So first prove the two triangles are congruent. So we've got our statements. We've got our reasons. And so I'm going to use angle, side angle for this. And so my first angle is the one at the top. I'm going to say angle STR is congruent to angle LTR, and that's given. What did it tell us about the other angle? They said that they're right angles, so I'm going to say TRS, angle TRS, is congruent to TRL. That's also given. But notice, I'm sorry, I didn't say it was congruent, did it? It said they were right angles. So let's just back that up. There's a difference. That was what was given. Now the next statement we do need to do the same thing. You say TRS is congruent to angle TRL. And the reason is all right angles are congruent. Now if you put they're congruent, that was given, I normally would take that, but we're trying to be technical. They didn't say they were congruent. We need to say what they said. They're right angles, and then we need to say they're congruent because all right angles are congruent. So I've got an angle here, and I've got an angle right here. I know that side TR is congruent to side TR, and that's the reflexive property. So that gives me a side. So now I can say the two triangles are congruent. Triangle TRS is congruent to triangle TRL by angle side angle. And then lastly, since the two triangles are congruent, the corresponding parts are congruent. So notice RS are the last two listed here, RL is the last two listed there. So I can say RS is congruent to RL, and the reason is corresponding parts of congruent triangles are congruent, or kibitic. All right? Well, I hope that helps you out. And if you have any questions, let me know, and I'll have some practice problems up for you here soon. Thanks for watching.